everyone, we're going to evaluate the limit and justify each step by indicating the appropriate limit laws. Both of these are polynomials, so all we have to do is plug in the value. So here's our limit laws here. They're kind of small, but let's justify each step. What we want to do is break it out using our number 1, our sum and difference laws. So in the way you do that, you're going to write, and it seems tedious, but it's going to be helpful when we get more complicated limits. So you're going to get the limit as x approaches 3 of 5x cubed minus the limit as x approaches 3 of 3x squared plus the limit as x approaches 3 of x minus the limit as x approaches 3 of 6. This was number 1 that we used. All right. Second step, let's use our constant multiple law. So what that means, you see this 5, these are constant, these two right here. We're going to pull them out front. So that's going to be 5 times the limit as x approaches 3 of x cubed minus 3 times the limit as x approaches 3 of x squared, and then we just copy the rest of these down. Limit of 6 as x approaches 3, and we use number 2. All right. The next step is we're going to apply the limits, and we're using these steps in here. So we're using basically all these steps. So basically what you can do is we're plugging in the 3 into all these x's. So we're going to have 5 times 3 cubed. Okay, that was, let's see, the power rule. So we're using some of these laws. Minus 3 times 3 squared plus 3 minus 6. And this we're using the constant multiple. So for the constant, if you find a limit and there's no variable, then you use the constant law. So we use a variety of those laws. Now to evaluate this, you can work it out, but you'll get 105. All right, and the next polynomial is this one. And so let's use some of our rules. We're going to use number 4, basically, or number 3, the product rule. So what we can do is say that this is the limit as x approaches negative 1 of x to the 4th minus 3x times the limit as x approaches negative 1 of x squared plus 5x plus 3. So that was the product rule, and that is number 3. Now we're going to use this one, number 1. So for number 1, let's break it out like we did this first one. So that one's going to be this equals the limit as x approaches negative 1 of x to the 4th minus the limit as x approaches negative 1 of 3x. Now for this part, let's break it down, and we're going to use the limit as x approaches negative 1 of x squared plus the limit as x approaches negative 1 of 5x, and then plus the limit as x approaches negative 1 of 3. All right. Now, the only thing else we need to do, and then we'll just basically use the rest of these, basically up into here, I think. So basically what we're going to do is use our power, where is that one? Number 5. Okay, this one we use number 1. So let's use number 5, and pull out these right here. So this is going to end up being equal to the limit as x approaches -1 of x to the 4th power minus 3 limit as x approaches -1 of x. All right? Times limit as x approaches -1 of x squared, and then we got to pull this 5 out, plus 5 times the limit as x approaches -1 of x plus the limit as x approaches -1 of 3. Now, since we've done that, this one we used was number 5. Now we're just going to evaluate, and we have to use these constant multiple. We're going to use this limit, number 6, for this one. So the rest, we just put it all together. And basically all you're doing is plugging in, should be -1, just plugging in your numbers into the x. So we're going to have 1. Now this is going to be -3 times -1. So I'm just going to change that to save space. That's going to end up being plus 3. All right. Now this one's going to be -1 squared is 1 minus 5, because it's going to be 5 times -1 plus 3. So for this one, if this is just a constant, you just write that constant down. That's like the horizontal line we do. So this is going to give you 4 times -1, which equals -4. And that's it. Here are some a reminder of what polynomials look like, in case you need a refresher. And that's it. Thank you. Have a nice day. Bye-bye.